understanding isotopes and assessing their importance. At the end of this lesson, students should be able to state the meaning of isotopes, list examples of elements with isotopes, determine the number of subatomic particles of isotopes, and justify the uses of isotopes in daily life. Click on the blinking button to proceed.
You have learned that all elements have their own specific proton numbers. Atoms of the same element, therefore, must have the same number of protons. Some elements have atoms that have different mass numbers. These atoms are called isotopes. Hydrogen, for example, has 3 isotopes. Click on each of the 3 isotopes to view the number of subatomic particles present. How do the isotopes of hydrogen differ from each other? They have different numbers of neutrons. Hence, isotopes are atoms of the same element with different number of neutrons. The most common isotope of hydrogen is hydrogen-1 or protium. The other 2 isotopes are called deuterium and tritium respectively.
Click on the blinking button to proceed.
Other elements such as carbon, oxygen, chlorine and bromine also exist as isotopes. Type in the correct number of each type of subatomic particles present in each of the isotopes shown. Please try again. Please try again. Please try again. The symbols of 4 atoms are shown. Drag and drop the 2 atoms which are isotopes of the same element into the empty boxes. Correct. Well done.
Click on the blinking button to proceed.
Isotopes of the same element have the same chemical properties. They form compounds with the same formula. This is because they have the same number of electrons. Do you expect the isotopes of the same element to have the same physical properties as well?
The boiling point of deuterium is slightly higher than the boiling point of protium.
Isotopes of the same element have different number of neutrons. They have different masses and thus differ slightly in their physical properties.
Click on the blinking button to proceed.
Carbon consists of carbon-12, carbon-13 and carbon-14 isotopes. Carbon-14 gives out radiation which is invisible. It is said to be radioactive. Isotopes can be divided into radioactive and non-radioactive isotopes. Radioactive isotopes or radioisotopes can give off radiation in the form of gamma, beta or alpha rays. These rays are harmful to life and in large amounts can even kill people. Radioisotopes, however, have important uses in our daily lives. Cobalt-60 is used to treat cancer patients. The gamma rays emitted from this isotope is used to destroy cancer cells. The radiation from cobalt-60 can also kill germs. Cobalt-60 is used to sterilize surgical instruments such as hypodermic syringes and scalpels. The radioactive iodine-131 isotope is used on patients with defective thyroids. The radiation given out enables doctors to trace the path of iodine through the body. In the food industry, gamma rays are used to kill microorganisms such as germs and fungi. It is also used to preserve foods such as potatoes, onions, and vegetables. Carbon-14 is used to determine the age of fossils and artifacts. Phosphorus-32 is used to identify the absorption rates of fertilizers in plants. In industry, beta rays are used to control the thickness of paper, plastic, or metal.
Click on the blinking button to proceed. The table shows examples of elements that consist of isotopes. Type in the correct number of protons, neutrons, and electrons into the empty boxes. Click on the blinking button. Complete the crossword puzzle. In this evaluation, you will be tested on your understanding. In this lesson, students have learned that isotopes are different atomic forms of an element which have the same number of protons but different number of neutrons. Examples of isotopes of hydrogen are protium, deuterium, and tritium. Some uses of isotopes are in medicine, archaeology, industry, and agricultural. Click on the blinking button to proceed.